I would like you to remark upon the tininess of this code. Now, in saying that, I'm cheating a little bit because I haven't really handled the special forms. Okay? And each special form is, you know, half a screen full of code. So by the time we're finished, it's 6 or 7 screenfuls instead of just 1. And I haven't shown you how to look up a variable in the environment, although that's pretty straightforward. If you know that an environment is a list of frames, then it's pretty simple for you to write lookup in environment, supposing that you have lookup in frame as a helper. But that's basically it. Oh, I'm sorry. I'm also cheating a little bit because I didn't show you read. Read is actually, hang on a sec, read is actually a little messy and ugly because it's dealing with individual characters that you typed. It says, oh, look, this character is an open parenthesis, so I have to do blah, blah, blah. This character is a space, etc. So it's messy, but it's intellectually trivial. You could write it if you really had to. Yeah? Okay, let me try to restate your question, both so that other people can hear it and to try to clarify it for me, too. When you first learned about the environment model, it was presented to you as being necessary in order to achieve the way we want scheme expressions to mean what they mean. And in particular, once we introduced mutation into the language, which we did with object-oriented programming, it no longer works to say we just substitute values into the body, because the value of a variable might change halfway through the body. So as a consequence of that, and as a consequence of wanting things to be lexically scoped, we had to invent this environment model. And that's true. Now, you're seeing the same environment model presented as a consequence of the way the language is implemented. And both of those things are true. This is an instance of a general point that I'll be coming back to at the end of the semester, which is in everything we do in computer science, there's a whole bunch of levels of abstraction. And at any given level, if you're being an engineer at a particular level, what you do is constrained both by pressure from above you, so sort of the needs of the higher levels of abstraction that they're telling you about, and by pressure from below, namely how your level is implemented. Okay, so what kinds of facilities are available for the implementation of your level? And that's exactly what you're expressing here, that you can actually see it both ways. If you look at the actual history of the way this developed, first there was lambda calculus, which was an entirely theoretical model for use by mathematicians and not as a computer programming language. It was an attempt to rest the foundations of mathematics on the idea of function, sorry, rather than the more usual treatment in which everything is based on set theory. So that was a thing for mathematicians. Then John McCarthy wanted to have a programming language in which to make assertions about programs, among other things, to do artificial intelligence research. And he, you know, came across this lambda calculus that Alonzo Church had invented and said, we can use this as a programming language. So he took the notion of lambda, came from Church's work, and he defined a not very good notation for representing that to a computer. And then the notation kind of got refined. The language hadn't been implemented yet. And then one of his grad students, Steve Russell, said, you know, if we represent programs this way, I can write a really simple interpreter for it in itself. He had started out trying to write a Lisp interpreter in one of the previous languages that existed then, which basically meant Fortran. And everybody was finding that impossibly complicated. And Russell had the idea, let me try writing a Lisp interpreter in Lisp. And he came up with basically this, but a little bit different, because they hadn't yet thought about scoping rules. And so they ended up implementing dynamic scope, which turns out to be the thing that you naturally invent if you don't think about it very hard. You know, I'll be talking more about scope in a bit, probably Wednesday. And then people started writing programs in this language, and we're having certain problems because of the use of dynamic scope. And so there was a lot of, you know, there's 5 or 6 years worth of research papers on how to solve this problem. And then finally they invented lexical scope, which, footnote, is what Alonzo Church had in mind from the beginning. So if they had read Church's papers more carefully, they would have gotten there directly, but they didn't. So there was this back and forth between what the implementers implemented and what the users needed. So the actual history of it is very complicated. But you don't have to recapitulate that history. You have the benefit of all that earlier work. And so you can see, you know, right from the beginning what kind of the right answer is to these design questions. I'm not, when I say the right answer, I'm not making a claim about the superiority of scheme over whatever your favorite language is. I'm just making a claim about the superiority of scheme over the Lisp of 10 years ago or 20 years ago. So yeah, this is exactly the same thing that you learned before. And it had better be the case that what we implement is what we needed, right? So you can view it as the needs giving rise to the implementation or the implementation giving rise to the behavior, and they're both true. That's an example of what we call a dialectic, where you have two kind of opposite things that determine each other. It's another example of circularity, in a way. Okay, we ready? All right. So I'm telling you about the parts we're leaving out. So we left out do special form. We left out lookup in environment. We left out extend environment, but that's totally straightforward. You could have written that in the first, well, as soon as you learned about lists in the 4th week, you could have written extend environment. And we left out read, and we left out print, which is slightly messy, not quite as messy as read. And most important of all, we left out storage allocation. So when you say map, and inside map there's a cons, how does that cons actually happen? That's something we have not discussed at all. It turns out to be probably the most complicated piece of the whole system.